Since multiplying inside the function I think is the most difficult type of transformation for students to grasp, let's look at one more example, this time using cosine.
So I bet you can guess what would happen if I multiply by 1/2 inside the function. So let's take a few key values for cosine. Here's one key value, 0 at 0 degrees, at 90 degrees, at 180, at 270, at 360. So if I want to make, if I want to look at the 1/2 x, so here's the point 0, 0, 1. If I put in 0 for x, cosine is still 1 because 1/2 times 0 is still 0. So I still get 1 for here. Let's say now that I put in 90 for x, then I would have cosine of 45. So I don't want to make that a key point. Let me put in 180. So if I make x equal to 180 here, I'm going to do this in a different color to differentiate from the previous problem. So if x is 180, f of x is going to be cosine of 90. Well, cosine of 90 is 0, so now I have the point 180, 0. So 180, 0 would be right here. What's another number that I could multiply by 1/2 to get a special number here? So to get 270, I would have to make x be 540 now to get the value at 270. So if x is equal to, once again I want to make this black, x is equal to 540, f of x is equal to cosine of 1/2 times 540, which is cosine of 270, which is 0. So at 540, I'm back to 0 again. So where's 540? So I guess what I should have done is the -1. Okay, I want to figure out how to get down to the -1 here. So if I put 360 in for x, cosine is 1/2 of 360, which is cosine of 180, and cosine of 180 is -1. So when I put 360 in for x, I get -1. And if I put 720 in for x, I get cosine of 1/2 of 720, which is cosine of 360, which is 1. So what happens now is my cycle has stretched like this. All of my angles have to be 2 times bigger because I'm multiplying them by 1/2 in order to get the same trig values that I had originally. So now the period equals 720. So this is 2 times wider than before. So this affects the period. Multiplying inside of the function affects the period. And it does the opposite of what we would think. So remember, anything inside the function does the opposite of what it looks like. So you multiply by 1/2 or divide by 2, the period gets 2 times wider. If you multiply by 2 inside the function, the period is half as big. So I want you to remember that when we get to the next section, because the next section is going to be really key in how we use radians effectively on a graph.